Okay. So I'm recording. Let's see. Does that work? Yes, I think that's going to work. Can you see everything okay? You bring us pizza. Oh, reminds me, happy Halloween, everyone. Sorry, I didn't say anything last time. And I'm sure everyone's now thinking about what's going on today. But anyway, just wanted to say that. Yeah. Well, luckily, you can, yeah, you can have whatever you want inside the comfort of your own home. That's the one nice thing about this midterm, right? Is you can just take it at home whenever you feel like it. Yeah. Okay, well, let's do categorical logic. You're over being at home. Yeah, it's not as fun as it used to be, right? When you just have to all the time. Yeah, that's true. Might actually be fun to go somewhere and take a test. How about that? Oh, I should hurry a little bit. Yeah, it would be fun, wouldn't it? Yeah, big pizza party. And it's fun to see people. I mean, I feel like I know some of you a little bit now through this, but just yeah, I miss having those real life interactions. Um, Although I see Maggie down the street, see her on my way to the liquor store. That's the only person of everyone here that I've actually seen. Okay, well let's get going with categorical logic. Okay, for some of you this may still be painful and it may sound too much like propositional logic, uh, but although some of you might like this a little bit better because it's more visual. Okay, there's not as many P's and Q's and F's and things to keep track of. Okay, there's a little bit, but it's not quite the same. So in propositional logic, it was basically all those four operators, right? Those are really what do the heavy lifting. There's these four operators, they're very well defined, and then you can go ahead and see if an argument is valid based on what those operators do and based on what kind of truth values we feed the argument, right? That's all we did in propositional logic. Okay. Now this is going to be kind of similar, but there's different types of deductive arguments that might work. There's other kinds that don't use that terminology at all, right? For example, this right here. All humans are mammals. No mammals are cold-blooded creatures. Well, what follows, right? If both of those premises are true, what has to be the case if all humans really are mammals and mammals are never cold-blooded? Well, then it would follow that humans are not cold-blooded. Right? Does everyone see that? Hopefully, just you see the intuitive logic there. But it's not using if-then statements. It's not really like that, right? Now, you could translate this whole thing into that kind of language, right? You could translate any kind of argument into the right format if you wanted to, right? So I could say something like, if X is a human, then X is a mammal, right? I could try to break it down and then put it back into propositional logic terms using those operators. I could, but that's really unhelpful when it comes to this type of arguments that use things like all or no, or as you'll see, some. They don't fit into it that well. So why don't we use a different kind of logic to evaluate those kinds of arguments? Right. Here's another one. Some humans are cheaters. All cheaters are liars. Therefore, some humans are liars. You can see that this is a valid argument, right? Um, if you agree with the premises, and again, you don't have to. You might say that you could be a cheater without being a liar, right? You might have a problem with number two. But that's not what we're worried about when we're talking about validity, right? Validity is just a matter of if the premises were true, would the conclusion also have to be true, right? And in this case, yeah. if it is really true that some humans are cheaters and that cheating necessarily involves some amount of deception, right? That cheaters are liars to some extent, then it would follow that some humans, at least the ones that are cheaters, are also liars, right? So hopefully you can see intuitively that there's all sorts of arguments like this that you can set up in such a way that the conclusion follows deductively from the premises. It's just that rather than using those operators like the conjunction and the disjunction and the conditional, rather than doing it that way, we're using these concepts of some, all, or none. All professors are boring people. No boring people are likable people. Right? If that were true, not true at all, of course. Right? Premise number one, I take great offense to that, even though maybe it is true. Anyway, if they were true, right? That's the takeaway, right? When you're looking at validity, you're not worried about the actual truth value of the premises. You're just asking the questions. If the premises were true, would the conclusion also have to be true? And in this case, yes. If it really is true that all professors are boring, and it's really true that no boring people are likable, right? That if you're boring at all, you're unlikable, right? Well, then it would follow that professors are not likable, right? It would just follow as a matter of logic, right? That's how you know we're dealing with the idea of deductive validity, right? So those examples that I gave you, they're valid, they're good deductive arguments, but they're not using those operators. And again, you could try to, it's kind of hard to do. We've seen that in other cases, right? You could try to translate it, but it might be really difficult to do. So better just to use this kind of logic that is already available to evaluate those kinds of statements, okay? And by the way, this logic that you're learning here, categorical logic, I have this piece of paper that's driving me crazy. Categorical logic was invented basically by Aristotle, the ancient Greek philosopher. Okay, that's how far back this goes. So he was one of the first people to really formalize this, to show exactly how logical reasoning works. And we can do it by using statements about groups or categories of things, right? All of something, some of something, none of something, right? We could so basically that's the way to think of it. Categorical logic, it's like group logic. Like you're talking about groups of entities, right? Groups of humans, the group of mammals, the group of cold-blooded creatures, right? You can almost imagine, this is what I do, I imagine gathering up all the members of that group and putting a big circle around them, right? The category of humans holds all humans and nothing else, right? Well, nothing non-human anyway, right? There's funny overlap that we're going to look at. There is an overlap, right, between humans and mammals, for examples. So you could say things like all humans are mammals, and that means all members of the group humans are also members of the group mammals. You see how that works? So these are basically like, imagine all the members of that category in one big group, right? That's what this is all about. It's group logic, right? It's categorical logic because we're talking about categories of things. And those statements are all going to involve either a statement about all the members, some of the members, or none of the members. Do you see how that's possible? Right? Again, before you even try to do logic or anything, just try to think of it just intuitively. Think about a category of things. Trees, pens, right? Mail-in ballots. Any category, right? You can talk about that group of things, and you can talk about either something that's true of all of them, something that's true of none of them, right? Yeah, face mask, sure, exactly. Pick your favorite contemporary reference, right? You could talk about all of the members of that group, some of the members of the group, or none of the members of that group. And when you do that the right way, when you have two premises that are doing this the right way, it will lead to a conclusion, right? So it's very similar to propositional logic. We just use slightly different terminology, and it's a different method of checking for validity. Yeah. Example, all humans are mammals, right? That's the example I just gave. That is basically saying that all the members of that group, humans, are also members of the group mammals. You see how that works? It's not saying that all the members of the mammal group are humans, right? Because we know that's not true. You could be a mammal without being a human. So the mammal group incorporates lots of groups. It incorporates cats and dogs as well. When I say all humans are mammals, I'm just saying that if you're a human at all, you are also in that mammal category. Yeah? And I could also talk about just a particular subsets, right? Some particular type of human, right? I could talk about the whole group, and I could say, well, some of those humans are cheats, right? Some of them cheat in various ways, right? These are, again, random examples. You don't need to read anything into them, right? That statement says that at least some of the members of the group humans are also members of the group cheats, right? Makes sense, right? So when you have the group humans, imagine all the humans in this circle. Now, all of them will also be in the mammal circle, right? All humans are also in the mammal circle. But there's only some of the humans that are in the cheats circle. Only some of them. No professors are likable people. This is saying that there's no members of that group that are also members of the group likable people, right? So imagine there's a group of likable people, all the likable people in the world, put them in a circle, and then put all the professors in a circle. You'll see never the twain shall meet, right? That's what this is saying. None of the members of the group professors are members of the group likable people. You know, and again, this is just an example, right? Not saying that this is true, right? Just giving you an example of that kind of thing that someone might say, right? Again, logic is supposed to a certain extent anyway, encapsulate what you already do, right? When you're thinking clearly and correctly, logic allows you to sort of formalize that and get clearer about that. And we're doing the same thing here. We use this kind of reasoning all the time, categorical reasoning. You're just not always aware of it, right? Or sometimes we use it in a really bad way, right? For example, when you make up your mind that all groups of a certain, all members of a certain group have something negative about them, right? You can see how things like racism and things like that might creep up in here. When you're used to categorizing an entire group of people, for example, and you have some sort of negative thing associated with it, right? So it's very easy for this to go wrong as well. But this is how we reason. This is how we look at the world. We come up with categories or concepts, and we look at the things that fall under those concepts, and then we can make logical deductions based on those statements. So, categorical logic is all about making valid inferences with those kinds of statements. Statements about groups or categories, however you want to look at it. And you should start getting used to the idea that it's groups of things or groups of entities rather than an adjective or something like that, right? For example, I could have said no professors are likable. That's a kind of a more normal way to say it, isn't it? Right? If I really wanted to say that professors aren't likable, I would just say no professors are likable. Right? But here we're not doing that. If you were to find a sentence like that, you do have to translate it a little bit. You have to say the second part has to be a group of objects as well. It cannot be an adjective, right? So that's why I say no professors are likable people, right? So none of the members of the category professors are also part of the category likable people. That's different from saying no professors are likable, where likable is just a free-floating adjective, right? Here, we got to make sure that we're always talking about groups of people, groups of categories. So even something as simple as the old example that we use, Socrates is mortal. You know, to translate into categorical logic, you'd have to say something like, all people identical with Socrates are people who are immortal, or are people who are mortal, something like that. We'll get more into the translation issue later, but it's just good to remind you, yeah, all people identical to, it's a weird construction, right? All people identical to Socrates, or all people who are Socrates, where you can cheat and just like, well, we know which Socrates we're talking about, but we just have to put it in the correct format. You can't say Socrates in propositional logic. You can't say a person's name. You have to treat that name as a category, right? So all members of the category Socrates, you could say it that way, right? Or you could pluralize Socrates if you wanted to, right? All Socrateses are mortal, but then you'd have to say are mortal people, right? You can't just say mortal. You have to actually. So in both the subject and the predicates, again, I'm getting ahead of myself, which I sometimes like to do on purpose, right? Just to get something in your head right away. When you're using categorical statements, categorical language like this, you're always talking about two groups. Right? You have to make sure that it's in the language of objects that can be put into a group. Right? So if there's an adjective, you just have to change it into whatever it is that adjective is describing. Okay. Okay. Well, we'll get more to that more. Okay. Just right now, the important part is that you understand that it's about groups that have members, right? Groups that have members. So instead of saying red, we would say red things, right? The group of red things, right? If I say the ice cream is melty, I'd say all ice cream, all things identical to this ice cream are melting things. It's a little awkward, but that's the way you have to do it. And just like before with propositional logic, right, I try to make it a little less intimidating by reminding you that there's only 4 basic operators that you really have to understand how to play the game. It's the same thing here. There's only 4 types of statement that we're going to be using. Okay. Now, there's weird ways of inverting those statements and saying them in different ways. Sure, but there are still only 4 different basic types of statement, okay? That's going to be a statement like this, or all SRP. For example, all humans are mortal beings. So notice, again, I didn't say all humans are mortal. Right? Mortal is an adjective. We're doing categorical logic, so it has to be category statements, category terms. And the category term is mortal being, right, or mortals. How you have some wiggle room for how to say it, but it's got to be in noun form. Okay. So that's one type. All humans are mortal beings, right? That has the form all SRP. Oh yeah. A lot of people learn some version of this in high school, or when you take I almost said the GRE. That's the one for grad school. I can't even the AT&T, the SAT. You might find that kind of stuff as well, right? Yes, yeah. So some of you will be familiar with this, right? Another type is no SRP, right? No politicians are honest people. Timely statements, but again, just an example, right? This is the type of thing people say, right? It's a categorical statement. You're making a statement about categories of things, right? You're making a statement about 2 different categories and how they're related. Yeah? Yes, that's right, Maggie. Yeah. I don't bother with the AEIO. I just call them by their longer name. So you don't have to know AEIO for this class. But yes, that's right. That's what they're called. You know this. Some SRP, right? Some people are hard workers. It's a type of statement people make. It's a category statement. You're talking about the group of people, right? The category people, human beings, and the category of hard workers. That's another category. And you're saying there's some members of the people group that are also members of the hard workers group. Yeah. Pretty simple, right? Again, this is ordinary language. You already know this. You already use these type of statements. Just now you know more strictly that these are category statements, and you can break it down into circles, right? And you're making statements about the relationship between those circles. Finally, the last one is some S are not P. Right? Some citizens are not taxpayers, as an example. Right? You see how that works? All S are P, no S are P. Some S are P, some S are not P. You see that? So now those 4 types of statements tell you the 4 different kinds of statements you can make with regards to 2 categories of things. Right? Take any S and P, right? S stands for a category of things, P stands for a category of things. For any of them, you can either say that all the members of S are also members of P, or you can say that none of the members of S are members of P, or you can say that some of the members of S are members of P, or you can say that some of the members of S are not members of P. Okay? With me so far? Oh, actually fun. Good. All right. Now, these are the technical names. These are the AEIO that Maggie was talking about. I want you to just remember these names. Universal affirmative. Universal. Universal means encompassing everything, right? So, all. Right? Here we're definitely talking about the whole category. All of them. Not just some of them. We're talking about all of them. That's what makes it universal. And we're saying that all of them are P, right? Affirmative. Universal affirmative. All S's are indeed P's, right? It's both universal and affirmative. You see? So it's just like denying the consequence, right? You can think of those as very technical terminology that you have to memorize, or you can understand what they're saying. Right? You can understand what the words mean, and then you can much more easily understand why it's called that. So any statement of the form all SRP is called a universal affirmative because it's talking about all the members of S, and we're saying something affirming about them. Affirmative. We're saying they are P. As opposed to no SRP, we're still talking about all the members of S. We're just saying that none of them are P's. Right? So it's universal. We're talking about the whole group, but we're saying none of them are P's. So it's a negative. Now you see the pattern, right? When you're talking about some, you're not talking about all of them. You're talking about a particular one or a particular set of ones, right? Some particulars within the overall category. Some of them are P, so again, it's affirmative because it's saying something positive and affirmative. It's saying they are P, but it's only those a few particular ones within the group. And then the last one you could probably guess, particular negative. Right? We're saying about some members of S not being P. So there's particular and negative. Okay? So get these in your head, right? I guess, oh yeah, it's time, so we'll stop there. Try to just memorize these 4 basic types of category statement, okay? Just like earlier, you learned the 4 different connectives. Here you're just learning 4 different types of category statements. So just try to get these in your head. And then we'll continue here on Thursday, okay? And if you have any questions about anything, remember you can email me depending on what your query is. If it has to do with grading, changing a grade or grading something from a while ago, that might take a little bit of time. But if you have a particular question about the final, or about the midterm or something like that, then I could help you quickly. The answers to the test, yeah. Nope. All right, see you on Thursday.